All right, parallel lines. Now, these are a bit deceptive sometimes. I do like parallel lines though, but we have various terms we use here, which are alternate, corresponding, co-interior, and by the way, we also have another one which is co-exterior as well. But we'll get to that in a moment. So the first one we're going to look at are alternate, or in fact, actually corresponding angles are probably the easiest one to understand. So let's say you've got a number of parallel lines. Let's say all of these are parallel lines, for example. Parallel, 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 parallel. And we denote that with an arrow. Now let's have a look. Let's say I have something going across those. And of course, the thing going across that we call a transversal. There it is. The line going through a parallel line or set of parallel lines is called the transversal. So there's our transversal. Now corresponding angles are going to be all the same angles on the same side. So that and that and that and that and so on. Yeah, these are all what we call corresponding angles. Corresponding. And the way to think about this is if I was to squish up all of those lines together so there was no space between them. In fact, here we go. So here they are a lot closer now, yeah? And I had my transversal going through, yeah? All of these angles would also, of course, all be the same. Of course, if I squish them up so much that really what I had was one big thick line and I had my transversal, then as you can see, with all the angles on the same point, with the transversal, they all must be the same angle. So if I squish all these up together like this to the point where I've only got one line, in other words, I've just got one line on my transversal, this angle here, between all of them, all squished together, must be the same angle. They all share the same angle. So they're all what we call corresponding angles. And we say that corresponding angles, we just write corresponding, angles, now the equal, comma. Now here's the important bit. The fact is corresponding angles are almost never equal, yeah? But they are between parallel lines, yeah? And you must say parallel lines, otherwise they're not. Here are some corresponding angles. Here we go. Here's corresponding angles. Here's one here. I'll go that one there and this one here, yeah? Here's my transversal. And these two angles here are what we call corresponding angles. But because these two lines are not parallel, although these two are corresponding angles are not equal. Corresponding angles are almost never equal. They're only equal in one situation, and that is between parallel lines. So you must include comma parallel lines. Without this one bit on the end there, it's just not true. So that's the first bit, and they are corresponding angles. Corresponding angles are equal. So let's say, for example, I had, I'll draw some up now that are equal. So let's say you've got one here, and these two are in fact parallel. And let's say I've got this angle here and this angle here. So I've drawn them on the other side this time, but again, they're corresponding. And let's say this was 120, and we said this was x. Well, x in this case would have to be 120. And the reason you would write is corresponding, and they actually put a P on the end, but corresponding angles equal, comma, parallel lines. And that would be the reason. So corresponding can be on the same side. As long as it's the same side, it doesn't matter if it's on the other side, and they're both on the other side, or both on this side, but they're still corresponding angles. All right, hopefully that makes sense.